So I was looking into the Go programming language, and something really interesting is they were talking about how that they wanted to make a programming language for the software, for the kind of software that they're making now. Of course, this was made nearly 20 years ago, I think. And that's just a really interesting idea, is that the programming languages of different times and the frameworks and like all this stuff was really to support the ecosystem and the programs and the operating systems and such of those times. And software and programming always evolves, and we went from a command line to a graphical user interface to now really advanced 3D graphics with graphics cards, and now we've gone to the age of like machine learning and LLMs and such, and it's just always continuously evolving. But there's one thing that stays the same, which is the fundamentals of programming and the fundamentals of essentially computing in itself. And I think one of the major fundamentals of, maybe we could say, computer science, if I'm not butchering terms and such, is file processing. And files are everything. Some people like to complain about the everything as a file idea. Personally, I think it's the only thing which really works, because at the end of the day, a program is just a compiled file. It's just a compiled piece of text, essentially. At least in the past, when things were more just terminal shells and such, really simple. Well, they weren't technically simple applications all the time. Some of them were, but nowadays, it's compiled. It's got all kinds of different files added to it as well. It could be audio, it could be whatever, right? Which, at the end of the day, an audio file is still a text file. A picture is still text. It's in data, right? Everything has to be written to data. It doesn't matter if it's 3D, it doesn't matter if it's 2D images, it doesn't matter if it's video, whatever. Everything is technically text, the same way that a video, moving images on a screen, is just lots of frames of images, right? Progressively over the span of a second, you have X amount of frames, 24, 30, whatever. So going on, fundamentally understanding files, file browsing, what is the basic generic kind of server that everyone has to learn for, like, if you want to do backends, they call it the CRUD server. Create a file, read a file, which means print out the contents of it to understand it. Update, which is really edit. Update means you go into the file, you read it, and you then change oranges to bananas or bananas to oranges, and then deleting the file, getting rid of it. Everything returns to null. It returns to zero, right? So these four things, create, read, update, delete, is very essential. Can you make a shell, which is not that hard? A shell is really just a while loop that prints stuff, that has a whole case of, if you want to do switch case, if you want to do if. I like if else. As much as people hate on them, I think it's quicker, it's more efficient, it's easier mentally for me. Of course, there's different. There's depending on how much data you're working with, will depend on when you need to transition from an if else to to for loops or to whatever, right? There's also other operations, which is running things. Of course, the create, read, update, delete is more just for data. Because one thing you have to understand is that servers and a lot of programming is, like a lot of the rest of the world, is made for corporate purposes, meaning for companies. What do companies want computers for? They want them for databases. You think of banks, you think a clothing shop, all these places want some kind of centralized database that they can access and be like, okay, someone at store number 53 bought clothing item 482 or whatever, and they bought one of those, and it's like it was worth this much, and all the data. So computers were really like a lot of the use and almost development, all this to an extent was databasing, right? If you look at SQL database, which is a pretty decent database system. These servers are obviously manipulating that, and then you just think like a server is just manipulating someone else's computer. You open a web page and you go on a website and you want to create a user. That is you accessing the centralized server, which is someone else's computer, to then create a file, right? You're just accessing a person's computer to make a file, which is your user, which is your username, password. It's what you've bought. There'd be like a Boolean value saying yes they've bought this, or no they haven't bought this, or whatever. So all of this stuff is, if you want to simplify everything. You want to see it really, really simple. You could run the exact same thing on a LAN system, for example. If you had a bunch of computers connected via a switch, you could run the exact same system, except now it's more, everything you can see in front of you. You can't see, I don't know, you log on to eBay, you can't see the eBay server. It's hidden in whatever factory, whatever area, right? But it's the exact same thing. It's file management, essentially. And then you want to think, what's a program, right? A program is obviously just text data compiled, and then your CPU is running it, and your kernel is acting as a interface between, it's acting as a way to allow you, the kernel of drivers is acting as a way to allow you to see stuff on the screen, what pixels meant to be where, to process audio, to print the things, to have the pictures where, and if you need to use to access keyboard and mouse and all this kind of stuff. So that's functioning in that way, and the program is accessing the kernel through the standard library in C, for example. You can access it direct through system calls, or you could just write assembly and use system calls as well to access things a bit more direct. But we have layers. Same with memory management. Most of everything you're calling on the stack, and the heap in most languages, I would imagine, is automatic. Your stack is your basic variables, for example. It's your basic, when you call an integer, it's on the stack, right? The heap is more, I haven't butchered this, or got it the wrong way around. It's more for like larger data sets. You need to store megabytes of data. If it's beyond like hundreds of kilobytes or whatever, I'm pretty sure then you have to put it on the heap at that point, because it's just too much data. So going on, if you learn to create your own shell and you get it to be able to do file management, because the C standard library handles file management through its file thing, or the file commands, right? That is just calling up, depending on your operating system. If you're running a Linux operating system, it's accessing the Linux kernel, and it's using the system calls of that. If you're on a Windows, it's accessing the Windows kernel and drivers and such, because it's got to access your hard drive or RAM or whatever you're logging everything onto, the storage, and then Mac, of course, for that, right? The reason that it's good to have like C is that it's compatible, or programming languages or whatever, because it's you don't have to manually like access the kernel and system calls and all this kind of stuff. It's not a bad idea to do that, though. That's the thing. It's if you basically just use a Linux system and you only want to make something for Linux, it's probably not a bad idea to learn that. But I'm going on. What I'm saying is that if you learn to make this stuff, and then you learn to get the program to basically like can you get a program to create another program? That's a really interesting thing. Can you, because you can do meta programming, or you can access pre-created programs, right? What is the shell doing? It's accessing programs. You have a calculator program or a text editor program. When you open up Vim or Nano or something, you're accessing a program through the shell, right? Can you make your own shell to do that? Because then you're at the point where you are now, you're not writing the kernel of the operating system or the drivers, but I'm starting to think about like embedded systems, so microcontrollers, right? ESP32, Arduino, Uno, all this kind of stuff, Raspberry Pi, etc. They're more of like partly a computer, though. I'm starting to think about this in the way of, if I can write a shell for these things, a GUI, graphical user interface, in a shell is essentially the exact same thing, except one of them is with text, the other is visually, right? Visually manipulating. So do you want to, because it's just how do you access files and programs, right? That's basically like, files is like your memory, your kind of yin, negative, and then programs is like your active, your yang, your positive, right, of computers. And files could be, again, images, videos, whatever. If the passive video is a video file, but then you run it, turning into the active, it's like heating up water. It goes from cold to hot. Now you're watching the video, right? Like that's the experience of a computer. That's the yin yang of a computer. Like what is beyond that? It's just you're playing, or a computer allows you to play around with the experience of the senses of reality. It's a simulation machine. Do you want to simulate pictures? The senses of the eyes? Do you want to simulate music? The senses of the ears? Do you want to simulate video? Do you want to make a video game, which is a little artificial reality? You can hear it, you can kind of feel it because it has physics, and you can use your keyboard, mouse. You're not really, you're not like grabbing and whatever you want, but you can kind of, and you can see it, right? You can't yet smell and taste video games, but in the future, there is definitely research on that, but you have to think like, what is the experience? What can we do with the computer? Because video games pushed computers a lot. Music, people who make music, synthesizers, who programmed all this stuff, pushed audio, right? People who make art pushed the visual side of computers. People who do these things push the different sides of virtualization. And then eventually people will, technically chemical factories who work with like perfumes and such have already pushed the smell side. They've got like databases of and they've probably got crazy technology locked behind to do with smell and taste and whatever behind whatever company door. And that's kind of the annoying thing of like the corporate system, because it's not open source, so you don't know what kind of crazy tech they've got. But that's kind of another thing, right? So that's what I'm thinking about, is if I get a microcontroller, an ESP32, and I program a shell on it, these things don't have a lot of memory, so you can't really put a whole lot of, can't really be putting pictures or anything. Everything has to be from code. You want to create a picture, you're going to have to create the GUI, the GUI through some kind of like a screens library to do that. That'd be an easier way, right? If you want to make a picture on it. But yeah, can I do all that stuff? Can I make like a calculator on it? Can I make like a text processor on this thing? How far can we really go with these microcontrollers? Because that's like recreating the computer. It's in an easier way, because these microcontrollers are very easy to use. It's USB-C. They've got a decent processor. They have all the pins there. It's 5 volts. It's not like in the past where you had to do power management and turn it down to like 12 volts, like the Apple One. If you look at the Apple One, You can see all the capacitors for the power management. They've probably got like a transformer and all this kind of stuff. And then they have all the different chips, like the CPU chip and like the chip to process language and like, again, you don't have to write the kernel and drivers for these ESP32 things, but you do have to write if you're creating. Just say you make a controller for this thing, you do have to program technically what is a driver for that controller, right? Because the whole point of these microcontrollers is to allow for an interface for hardware. And that's what these things are. You allow for an interface for hardware, right? So you're essentially, that's why it's low level. And it's kind of like a pseudo driver, I guess you would say. Just a simpler one, because usually you would do drivers would be if you want to look into serial, and serial is just like sending text data over either Bluetooth, Wi-Fi, or USB, or really anything can send, anything electrical can send serial, because it's just like pulses of electricity. Is that how it is, or do they use something else? I don't think it would be like frequency modulation or anything. I would imagine it's just pulses. Something like low voltage pulse or something. I don't know. Basically, it's just text data. When you hook up the ESP32 or the Arduino or whatever to a computer, and you open a serial link, that's how you get it to send you back text, right? To send you back, and then that's how USB controllers and USB keyboards and like a MIDI keyboard or like, I don't know, USB flight control thingos work, because they're sending back data based on like a stream of text data. I would imagine, I'm pretty sure that's how it works over serial. Correct me if I'm wrong, but I'm pretty sure that's how USB functions. I'm pretty sure that's how Bluetooth functions. I'm pretty sure that's how you have a remote control to the TV. It's just sending data through whatever megahertz frequency it's using, right? And it has decoders and all this kind of stuff, encoders, decoders. It could have safety, security, lots of other stuff. But it's pretty simple, right? It's pretty simple. It's pretty it's all. That's why this is called information. I would imagine that's why it's called information technology or communication technology or whatever. It's all. If you can understand, everything centers around text. And if you grow up in a GUI world, graphical user interface world, and I love graphical user interfaces. I think that's the first thing I wanted to do when I was programming. I was like, how do I make a GUI? I don't like these command lines, and now I love command lines, and I can see the simplicity and the greatness of them. But when I first started, all I wanted to make was a GUI. I should have learnt web programming first, probably, but I wanted to make software. So, Raylib is an excellent library for C. SDL is another one, or just use like a game maker. But if you really want to understand computers and the computer world, everything is just obviously everything is electrical signals and electrical components. You look at how memory works. It's just a transistor, which is an electrical switch being turned on or off, and then a capacitor to store the data, right? So your memory is just, how do you electrically create an on or an off? Do you use a capacitor? Do you use a magnet? Do you use whatever you want? Everything is just this low-level electrical signals, 0 and 1s, positive, negative, whatever, south pole, north pole, building up into larger, more complicated circuits through like transistors, making logic circuits and all this kind of stuff, allowing for, because then if you think about this, calculators are one of the first real like marvels of computing. The humble calculator, which I looked at, last night, I saw you could buy a standard business calculator for $10 and a scientific calculator for $17. I mean, that's crazy. That is absolutely insane how cheap they are. But nowadays with software, you can just program one of these on a $5 microcontroller. You can program one of these on a phone. Everyone has them on their phones, but these things are actually profound, right? The calculator can calculate with numbers. The computer, the terminal computer, can now calculate with words. So instead of saying plus and equals, we're now saying if, else, while, to make a loop, right, or like go to for like basic, right? We're now using words, and words essentially open up a whole new reality. And then eventually we moved into the two-dimensional, you think like Nintendo, like NES, SNES, Sega Genesis, Sega Saturn, all these like really strong 2D consoles. This is like the 8-bit, 16-bit. We're unlocking two-dimensional graphics. I mean, technically they had two-dimensional graphics ages ago with like ASCII, and they even had 3D. Some people made 3D graphics with like space and flight simulators on old-ass terminal computers going on. And then eventually, you unlock 3D graphics, and you unlock audio, and we're able to now use these things to make experiences, to kind of calculate, so to speak. It all comes back down to text, which then comes back down to basic CPU instructions. If you look into RISC to see the basic, like add one thing to this place, remove one thing from that place, store this thing, whatever, right? Which then again comes back to the electrical signals. If you can understand that concept, just communication and words are important in basic signals. So I think I've rambled enough. I'm going to edit this. Have a good day. If you're still watching to this point, I hope you enjoyed it. I hope you learned something, and have a good day or night.